Hello everybody. So far we have seen Python fundamentals. We have covered variables, control statements, functions, and how they interact with each other. In today's chapter, we move from fundamentals to concepts. One of the core concepts of Python is object. We have frequently mentioned that Python is an object-oriented programming language, and it is actually one of its important selling points. By the end of this chapter, you'll be able to achieve the following outcomes, inshallah. Before we tackle the object concepts, it's important to point out the differences between object-oriented programming and procedural one. Programming with procedures is something that we are familiar with, and that's what we have already done with C programming, for example. It is the traditional way to write programs. Procedure-oriented programming is a method of implementation in which programs are decomposed into a number of subprograms, known as functions. Each function accomplishes a particular task. Generally speaking, programming in procedural languages involves choosing data structure, designing algorithms, and finally translating algorithms into code. In procedural programming, data is separated from operations, and the concern goes to how correctly send or pass data through the chain of subprograms. The procedure-oriented programming involves 6 main phases. First, we define tasks to be performed. Then, we break tasks into smaller and smaller pieces. Then we define the idea to be manipulated. Then we design how functions interact with each other, what will be the input and what will be the output. We group functions into components called modules. Finally, we write the code. Now we go for the concepts of object-oriented programming. What is OOP and why is it important? OOP is a different style of programming where all focus goes towards data or objects. In procedure-oriented programming, data serves procedures. However, in object-oriented approach, subprograms serve objects. In OOP, everything is centered around the object. The concept of objects encapsulates both data and subprograms. For objects, data are known as attributes and subprograms are called methods. As we mentioned, OOP is centered on objects. Its goal is to model the real-life objects, such as cars, computers, students, and so on. To model an object, we start by choosing the name for that object. That's why objects are noun-oriented. Then we need to focus on the domain of the program, which is the complete set of possible values of the object. For example, we choose a student as an object name, all the freshman students of TBS as the domain. To object-oriented programming modeling involve 3 main phases. Object-oriented analysis, in which we define the model. We have then the design, in which we design the solution. The last phase would be programming, which is building the solution. So far, we have understood that Python is a programming language that supports objects. But before we learn how to program using objects, it's important to get a better understanding of them. 4 pillars concepts are related to any object: a class, a method, an attribute, and an instance. What is a class and how is it related to an object? A class is something that you can think of as a blueprint or a template. So you may think of a template, for example, for TBS registration. Now, if you want to register in TBS, they will give you a form or a template to fill in this template. It will have certain attributes, certain fields like student name, student age, nationality, and so on. Now, this template is the class. It is not personalized. It can handle any TBS students. It has all the common characteristics of a TBS student. Now, once you personalize this template, you fill in with a given information. This will be like instantiating an object. So, let's take an example of car. In this case, the class name would be car. When we think of a car, all cars have a full type and maximum speed. Now I want to create an object out of that. I would say its name is Polo, for example. Its full type diesel and its maximum speed is 180 km per hour. Later on, I could use this very same class and I would create another car. It's called Mini Cooper, for example, and its full type will be gasoline and its maximum speed would be 228, etc., etc. So as you can see, you could create hundreds of cars objects from the same class. So I would create one template, one class, and 100 of objects, for example. So having a class, I can keep creating objects as much as I want. All of those objects would share the same attributes, which are in this case the full type and maximum speed. They also can have a behavior or defined capabilities such as refueling the car when fuel level reaches a certain threshold, or setting the maximum speed to a certain value. Those are called methods of the class. So here you have further explanation of a class and object. Now here is the example of the car that we have covered already. Now let's take another example of a class, which is dog. A dog has a name. Let's say the dog name in this case would be Lassie. Now all dogs can do certain things, certain behaviors. For example, barking, sitting, eating, and walking. So let's define those as methods. Bark, sit, eat, and walk. Those would be the methods of my class, and I would have one attribute, for example, which is the name of the dog. Now what is an instance? An instance is the actual object created at runtime. The set of values of the attributes of a particular object is called its state. Now an object consists of two main parts, the state and behavior. The state, which defines the attributes values, the behavior would be the methods of this object. You can see in this slide an example of a class which is bicycle. The notation of class in Python, we use the keyword class followed by the class name, as you can see here, class then bicycle. Then we use a colon. Then we have gear and speed, which are the attributes of this class, followed by some methods. In this case, we have three methods, which are speed up, change gear, and apply brake. Regarding the init method, this is a special method that we'll talk about later in this chapter, inshallah. Now let's talk about some benefits of object-oriented approach. It will save the development time and cost by reusing the code. As we said, we create the class once and then we can instantiate number of objects as we need. It's also easier to debug because classes are tested independently from objects. Another thing, it's easier to develop using objects because it's closer to the human nature. We think in objects because real life has entities and objects. Finally, we are here. So let's get to our business now and start programming in Python with objects. So far, we have always programmed in Python using objects without you knowing. Tuples, lists, dictionaries, strings are all examples of objects in Python. First, we should define the object's blueprint, which we call the class. So you can see here an example of a class student. This class has two attributes, the full name and age. It has one method which is getAge. Hold on, the init is not yet. We'll come to it, don't worry. Okay, now that we have defined the student class, we can create as many student objects as we want. In this example, we are creating three different objects, student 1, student 2, and me. In order to instantiate an object, we simply give it a name. In this case, we have student 1, the name of the first object, then we have student 2, the name of the second one, and me, the name of the third one. Then we assign to it the class name, which is a student in this case, and pass the attributes values. So for example, for student number 1, we pass the string value Ahmed, which will be assigned to the full name attribute, and the integer value 20 will be assigned to the age attribute. Eventually, the arguments will be passed to the init method internally. Now we are finally tackling this mysterious method init. What you should know about this method is that it is simply a special method. It's called constructor. The name init is the shorthand of initialization. It should be as it is, init delimited by double underscore. It's called a constructor because it constructs an object with the attributes values given to it. The init method can take any number of arguments, and just like other functions, the arguments can be defined with default values, making them optional to the caller. So far so good. Nevertheless, we should know more about the special argument named self, the first one passed to the init constructor. Self. The first argument of every method is a reference to the current instance of the class. If you are familiar of any programming language, then it will be familiar for you. For example, in Java, we use the keyword this to refer to the instance of the class. So now, if we create an object student1, self will refer to student1. And when we create object student2, self will refer to student2 object. At this point, all you need to know is you need to pass self as the first argument of any function when you define it in a class in Python. Now, after creating objects student1 and student2 from the student class, how about we display their attributes or methods values? So far, what we have studied in Python was simply displaying the content of a variable. So for example, in order to display the content of a list, we put the list name inside print. Now let's do something new. In order to display the object attributes value or methods values, we'll put the object name dot the object attributes or the method name. So you can see here in the first print, we are printing the full name of student 1. So we are writing the object name, which is in this case student1, then dot, full name, which is the attribute name we defined in the class student. Now, similarly, in the third print, we are printing the age, but not using the age attribute, using the function, the method getAge. So we'll put the object name, which is student2 in this case, dot getAge. Notice that getAge has no parameters because the way we defined getAge in the class student, it does not have any parameters. Speaking of methods, as we mentioned earlier, programmers can define any additional methods in their classes. The self parameter has to be explicitly mentioned as the first parameter in any function, as we said earlier. However, when the client calls a method of an object, it does not specify the self keyword. Okay, so as you can see in the table, the self parameter must be explicitly specified when you define the method, but it shouldn't be included when you call the method outside the class. Don't worry about the self when you call a method. Python will pass the self automatically. Getters and setters, also known as accessors and mutators respectively. Getters are methods that return an attribute. Setters are methods that set an attribute. So you can see here GetName will simply return the name of the student. For example, setName will update the attribute name according to the parameter new name in this case. We use getters and setters to hide the internal structure of the class students. So we cannot access directly full name attribute of class student. We need to go through the getters and setters. GetName in order to return the student's name. SetName will set the name. Now we have two versions of GetName. In the first one, we simply return the full name attribute. However, in the second one, you will return a concatenation of the two attributes first name and last name. They will be returned as one string value. For age, set age, we have also two versions of code. The first one is the simple one without any control. However, what if I want to validate the age before updating my attribute, which makes more sense? So in the second one, I will check if the age sent by the client less than 0, then I will assign 0 to the age, which is the minimum, or assume 1, whatever assumption you want to do, or for example 18. Then you will print an error message. Otherwise, of course, you'll assign the correct valid age sent by the client to my attribute. Now, why using getters and setters from the first place? Okay, in procedural approach, we don't have protecting data or data hiding. It's less secure. However, in object-oriented approach, thanks to the setters and getters and private attributes, we can do data hiding. So, the client cannot access or update the attributes without the permission of the getters and setters. This will give us data encapsulation. Yet again, under the context of data protection, we evoke the concept of public and private attributes and methods. Broadly speaking, public means everyone is allowed to access. Private means that only members of the same class are allowed to access. By default, Python attributes and methods are public. To make them private, you simply add double underscore to the beginning of the name of the attribute or method. Some interesting facts about public and private members. Public can be accessed by all the members of the class plus outside the class because they are public, they are open. However, private members can be accessed only by the members of the class. Now we have student class revisited. This is the proper way to write the student class. We define the attributes name, last name, and age as private attributes by adding double underscore at the beginning of the name. Now, in order to access those attributes, you need to use getters and setters because they are private. You cannot access them directly. In object-oriented programming, once we are done with an object, we deconstruct it. So we free the memory from this object space. Freeing an object refers to destroying it. Luckily, in Python, we don't have to worry about this because this happens implicitly by automatic garbage collection. We finish this first online tutorial with a simple exercise where we are asked to write a Python class named rectangle, constructed by a length and width and a method to compute the area of a rectangle. Hold on, don't move to the next slide. Try to do it yourself. Here we are. This is the solution. We are defining class name rectangle, and then in the constructor it takes two parameters, L and W respectively. Don't forget the self. Then this constructor assigns L to the attribute length and W to the private attribute width. Now, rectangle area simply multiplies length by width and returns the value. Now, you can see at the bottom, we are creating an object named new rectangle, in which the length is 12 and the width is 10. Then we are printing the rectangle area. It would be 120 in this case would be printed in the screen. Thank you very much and see you next lecture inshallah. Stay safe.